Next. The direction of the field, extremely important thing for me. At any point on the field line, is along the tangent drawn to the line at that point. If I have a field line having this structure, I can create at this point. You draw a tangent, say this is the field line E. This is point 1, this is E1 bar. This is point 2. This is the tangent drawn to the curve, this is E2 bar. Along the tangent drawn to the curve field line at that point, then it is a curved line. It can be a curved line, you know that. Listen carefully. The direction of the field at any point on the field line is along the tangent drawn to the field line at that point. Listen. Since E bar at any point should have fixed magnitude, correct only, and direction being a vector quantity. Let me add that. Since E bar at any point should have fixed magnitude and direction, no two field lines intersect. They can never intersect. Why? Suppose I have two lines which are intersecting. If I have two lines which are intersecting, at the point of intersection, red line tells that the field is along this direction. Green line tells that the field is along this direction. Field cannot have two different directions at a point. There can be 1,000 components. But as such, the electric field intensity will have fixed magnitude and direction at a point. So only never two flux lines will intersect. Listen. I think properties I'm talking about. Mm. They appear to be in the state of tension they appear to be in the state of tension and exert the force on the charges so as to minimize the length shorten to the minimum point or regain their original shape. This is the point that we need not worry much about, but still, because I'm talking about the properties of field lines, this can never happen. That's what you can see. If there is a positive charge and a negative charge, the field line will go from positive to negative charge, and there will be attractive force on each charge, because of which they move towards each other and the lines get shortened. If there is a positive charge near a positive charge, the field lines will be like this for both. They repel each other, because of which it moves away. When it is there here, the deformation is less. They come closer and closer to being radial, correct? If this charge is basically moved far away from it, they would have almost regained their radial nature. Like no elastic members. Because of the presence of the other positive charge, they become curves from the radial lines. And the field exerts the force in such a way that they move away from each other, restoring the original shape of the field lines. Please check. Listen carefully. The extension of this. when an object is charged, normally the charge comes onto the surface, is what they say. Charge comes onto the surface. In the course of time, we are going to prove also that if there is an excess charge created inside the volume, it dies down to zero at that point. Dies down to be zero because it got dispersed. We talk about, I told you also that there we talk about charge relaxation. When an object is charged with plus or minus charge, the charge comes onto the surface. Point one. Now, if the surface is infinite plane, if the surface is infinite plane, if it is positively charged, at any point, half of the charge will be there above on one surface, the remaining half will be there on the other surface. If it is a plane. If I take a curve, because here the flux lines get emitted like this. Half of the flux lines will go up into the medium, half will go down into the medium. The flux always that comes out from a surface comes in a direction perpendicular to the surface. I told you. Here there is no conflict. But in this curved surface, if I say that the positive charge is there on the top surface, what will happen? In the direction perpendicular to it, it comes. It should happen. Now the charge distribution will be like what? Positive charge here, positive charge here. So that these flux lines, somewhere they will be on the top surface, somewhere they will be there on the bottom surface. And the charge redistributes on the object in such a way that the flux lines never intersect. Going forward. Suppose a metallic sphere is charged. Suppose a metallic sphere is charged. No charge resides on the inner surface. Entire charge comes out onto the outer surface. Why so? If half of the charge is there on the inner surface, the positive charge basically produces radial lines going towards the center, because of which all of them will intersect at the origin, at the center. That cannot happen. For sure, whenever there is a charged object, charge comes onto the surface. If it is solid, if it is hollow, spherical surface. There is one inner surface, there is outer surface. There will be no charge on the inner surface because if there is charge at the inner surface, the flux lines emitted by the charge should intersect at the center, because of which entire charge comes onto the outer surface naturally. Please check it. When an object is charged, please remember, the charge resides on the surface. If it is open surface, plane, it will be equally distributed on the top and bottom surfaces, or the surface 1 and surface 2 of this open surface. If it is a curved surface, it's like this. Here, the charge will redistribute in such a way that the flux lines created by the charge never intersect. Check it. Any other thing that I have to tell as a part of theory? We have to see. I'm now ready to explain whatever you want. I think I'm done for today, because beyond this, there are derivations for me. I have to derive the expressions for the field quantities, and wherever there is a kind of symmetry, I have to use indirectly the flux lines and then nature of the flux lines, and then determine the field, as well as using integration determine the field. So that we can very smoothly get into Gauss law applications also. I'm ready for the discussion. You can ask. Tomorrow it will be purely mathematical. We'll see many things. And everything, in my view, will be based on the discussion that we had till now. I'll say we know that because we discussed. This is true because of which this is the way in which I have to do. Charge on a charged object. Charge resides on the surface of the charged object in such a way that no two field or flux lines intersect the point. Now, as and when we derive and start seeing the field quantities, we'll talk about more and more symmetry structures and then try to determine the field quantities directly in the case where we cannot determine it by using integration. I will show such cases also. Tomorrow, many derivations I will see tomorrow morning session. Because of which I think by afternoon we should be talking about divergence, Gauss divergence theorem, surface integral, volume integral, to be discussed on Monday anyway for the sake of doing problems. Please check. Any doubts? Okay.
Sir, I had a question.
Tell me.
Sir, you mentioned that the field lines appear to be in a state of tension. That's one of the properties. What is exactly meant by state of tension?
Means in an elastic object, elastic line is deformed. It is there in the state of tension, because of which, deformed by pulling it, what will happen? It tends to shorten. You can create tension in the wire in an elastic rubber band by pulling it, right? Or hold the ends tightly and then deform it by putting a line, using a stick or finger. It comes into the state of tension and appears up and exerts the force in the opposite direction, correct? You normally just relay a rubber band will not be there in tension. It's an elastic object. If I pull them or hold them and then deform, change the length of it either by pulling or deforming. It's an elastic object which produces restoring force, correct? We say that it is in the state of tension. Is it clear or should I?
Yes, sir, it's clear.
Tend to shorten or regain its original shape. An elastic member, when it is elongated or deformed, will produce a restoring force. When it is producing restoring force, we say that it is in the state of tension. Some more. Of course, some are the statements given by somebody. Ultimately, at a later stage, we can prove that they are correct.